Hello, everyone. I'm Jim Garrison. I want to welcome you to this session of Humanity Rising as we take a deeper dive into the cosmic soul. We've had a very eventful beginning for our Humanity Rising program for 2024. We started the first week with Richard Dolan looking at the facts as he knows them as the preeminent historian of UFO history about this extraordinary phenomenon that's bursting into public consciousness. And then last week, we looked at the science of consciousness and what is available to us as human beings with extraordinary psychic and intuitive faculties, largely untapped because the prevailing culture denies their existence, but nevertheless profoundly real. We explored that because, by all accounts, the way the extraterrestrials who have been present on our planet communicate is through mental telepathy. And so remote viewing and mental clairvoyance of all kinds is a necessary prerequisite if any of us want to have intelligible communication with these extraordinary beings. One of the things that we're all having to take in since the momentous legislation passed by the US government last December is that we have moved from BC to AD. You know, the way the Christian calendar has been structured, we're in 2024 because 2024 years ago, Christ was born. And so we mark our calendars BC and AD. And what we're now beginning is an even greater transposition between before disclosure and after disclosure. It's an extraordinary moment. And I wouldn't be at all surprised if in a few years we begin to develop a whole new calendaric system after disclosure. So 2024 is in some ways year one for the human race as it begins to take in the reality that we are not alone. And so what is up for humanity at this moment is a phenomenon that is going to transform every single aspect of what it means to be human. And we're going to be exploring the cosmos now, not as some faraway abstraction that you learn about in your astronomy books, but as our neighborhood, as where other life resides. Life that is as different from us as the different stars and planets and galaxy are different from one another, but life nevertheless. I mentioned last week that the James Webb telescope has been sending back data as it hurtles through space, looking for extraterrestrial intelligence, looking for extraterrestrial life, and that the rumors are swirling that it's found more life and what they think is life on a planet 120 light years away that's 8.6 times bigger than our planet, mostly ocean, but also land. So we're delighted today to have with us a cosmologist and an astrophysicist who really studies deeply the reality of our cosmos, Kala Perkins, who you all know because she's been on Humanity Rising a number of times before. She's our resident cosmologist who has the distinction, in my mind, of not only knowing the physics and the astronomy of cosmology, because she attends all these scientific conferences and is in touch with the latest research, but also whose heart and soul is deeply immersed in Eastern mysticism and the mythologies of the collective memory of humankind, so that the science and the mysticism in Kala's presentations are always mixed in a very informative and an illuminating way. So I'm very pleased, Kala, to welcome you to Humanity Rising. And Kala is going to comment on the latest research and also comment on, what James Webb is actually finding out there and, what her perceptions are about extraterrestrial presence on our beautiful blue dot, as Carl Sagan called our planet. So Kala, thank you for joining us once again and welcome.
Thank you so much for being here. It's wonderful to join you again, all of you, Humanity Rising. You've had a leaping a festival into the new year, and I'm delighted to be able to add a bit to that. Yes, I'm also excited to share with you some thoughts and humble at the same time, because I know not that much more than everyone else, and much less in many ways, but I'm delighted to share with you what I have garnered. So are we ready to leap off here into the universe? So what I'm going to share with you today is about, now what I would like to do is move these. There we go. Okay. I'm going to share with you about a wonderful telescope called Alma. And we'll explore what that means in terms of astronomy and astrophysics. But to start with, they were deciding what to call this amazing telescope on the high summits of the deserts of Chile. And Alma is what they chose. And when they were looking at the acronyms, which we will look at in a moment, and someone came up with Alma, Catherine Cesarski, who was once the head of the International Astronomical Union, a wonderful, wonderful astrophysicist, a wonderful person, said, we have to choose it. It means the soul in Spanish. So we are going on a deep dive into the cosmic soul. And so what we're looking at here, which is truly wonderful, is an Einstein ring. So the blue color is the visible image of a deep galaxy cluster in the distant universe, the early universe, with the Hubble Space Telescope. The blue is the visible light. The ring is in radio frequency, which is what Alma uses, as it is gravitationally lensed, and we will look at that, by a distant, so the galaxies in the front, the cluster of galaxies in the front that we see in blue light are being lensed. And what we're seeing is a whole cluster of more distant galaxies as its light reaches us, being lensed by the closer galaxy. We'll explore this technology that the universe uses. So here we go. And of course, Einstein predicted this, and 100 years later, we're taking photographs of what he had in his distant imagination. All right, so here we go. Can you see the top of my screen? Anyone?
Yes. Yes.
Okay, great. All right, here we go. So Alma, the Atacama long millimeter array and submillimeter array, that is what Alma stands for in astrophysics. Alma, it means soul in Spanish. It is a radio telescope, a huge radio telescope, maybe the largest in the world now. The Atacama large millimeter and submillimeter array. Astronomy loves acronyms. We have Psyche now, one of the space telescopes floating around our Earth. with wonderful meanings. All right, high in the dry Chilean desert at 5,000 meters, shielded by the Andes to the east, the Atacama Large Millimeter Submillimeter Array is the precision multi-tool for mapping the detailed but once hidden activities of the cosmos. It came online in 2013, about 10 years ago. So we just had this amazing and wonderful conference in Chile, Alma at 10 years. I attended it and it was a delight. So Alma is the premier telescope for studying the first stars and galaxies that emerged from the cosmic dark ages billions of years ago. The plethora of other solar systems, protoplanetary nebula, that means new solar systems just forming, and the origins of life in the cosmos. So we're going to find that there are lots of cooperations with these different telescopes at different frequencies. What we can see in visible light, what we can see in gamma rays, in infrared, in ultraviolet, and in our radio frequency. So there are 43 international observatories in the north of Chile. We have the desert, the northern desert of Chile here. Chile, to the south of us in South America, I think you all know where it is, has become a premier, one of the world's premier sites for astronomical observations because of this incredibly high desert. There are also new telescopes coming online there. One of them we see here, which will be one of the largest in the world with its mirror. And we're literally beginning to map, like we mapped the Earth many years ago, our universe, which is awesome when we think about it. So you can go to Wikipedia and look up the list of observatories in Chile. So these are just a snapshot of some of the various ones, and you can actually go on a tour of the observatories of Chile if you would like, from Sky and Telescope magazine. Okay, so let's look at Alma now, and we're going to appreciate a national radio frequency video. The best thing is to take you there. This is the high desert plateau. They're like 66 years listening at the summits of the Earth to the universe. And they're mobile. They move around and focus in different places in the universe and act as a single radio telescope. Extreme precision. It is the world's most powerful telescope for observing the universe. Cosmic origins, new baby stars, solar system. And we're looking at the origins of life. So this specially built extremely fast computer is up at 3,000 meters, 2 or 3,000. And it is an amazing collaboration between Japan, Europe, and North America. So I thought it would be the best thing to do to get to know Alma is to take you there so that you could see it for your own experience. So this is the night sky, the maybe 12 hours, 10 hours of the universe orbiting. And we're looking at the South Pole here. That's one reason why Alma is so magnificent and why we have all these telescopes in the Southern Hemisphere. The southern sky looks different. The southern Milky Way is different. We have a different viewpoint, a different vantage into the deep heart of the Milky Way. Sagittarius A, our black hole in the center of our galaxy. Hawaii is closer to the equator. It's our southernmost point in the US, and it's also an excellent site, but Chile gets deeper into the southern sky. And if you have any questions, please gather them, and afterwards we'll have some time to talk about them. All right, so we're going from the dark ages to cosmic dawn. First, there was darkness. Then a group of astronomers from the Max Planck Institute for Astronomy robustly timed the end of the epoch of reionization of the neutral hydrogen gas to about 1.1 billion years after the Big Bang. So we'll explain this. Reionization. Ions are when the particles, when the atoms are excited and the electrons can jump a shell and send out a photon. So we have light. If it's not ionized, we don't have light. So it began when the first generation of stars formed after the cosmic dark ages. We'll look at what that is. It's a long period when neutral gas alone filled the universe without any source of light. The new results follow from the radiation signatures of 67 quasars. Quasars are very hot, dynamic baby galaxies with black holes in the center. With imprints of the hydrogen gas, the light passed through before it reached the Earth. Pinpointing the end of this cosmic dawn will help us identify the first stars and galaxies. So here, let's look at this visualization here. We have what we call the Big Bang, a burst of energy, a burst of tremendous light and radiation in the universe. And then it became like a dark plasma, just a gaseous plasma with no light for about, that was about 300,000 years ago. At about 400 million years, stars and the nascent galaxies formed. And about 1 billion years ago, they say 1.1 billion years ago, the dark ages ended because the stars gave us light, the beginnings of the light that we see. And this light, this ancient light, has passed through what they're calling a group of 67 quasars, these early galaxies. And as the light of the quasars comes through space and reaches us, we can tell what the chemistry of that light has passed through. We can understand then what the early substance was in the beginnings of the universe. It's like a telescope. The universe itself is like a time machine and a telescope that we can look at using the light as our tool. So phase transitions from cosmic dawn. We'll go back here. The universe has gone through different phases from its beginnings to its current state. During the first 380,000 years after the Big Bang, it was a hot, dense, ionized plasma. After this period, it cooled down enough for the protons and electrons that filled the universe to combine into neutral hydrogen atoms. For the most part, during these dark ages, the universe had no visible light. With the advent of the first stars and galaxies, roughly 100 million years later, that gas gradually became ionized by the star's ultraviolet radiation. Once again, this process separates the electrons from the protons, leaving them as free particles. Then they could form the stars. So this era we refer to commonly as cosmic dawn, and I love that. And you see this beautiful visualization here. I was fascinated by it when I found it from Perimeter Institute. It's just like the images we used to have of the Empyrean in the Middle Ages. And we'd put the Earth in the center and the solar system, our planets and the stars and the galaxies, the universe, and God outside of the Empyrean. But what they've done is put our vantage point. So what we understand, we see every point in the universe is the center. This was discussed by Leonardo da Vinci's teacher many, many years ago, that the center is everywhere, the circumference maybe nowhere, he said. But this idea that every point is the center of a perspective, of a point of consciousness. So we see the universe from where we are. We're looking out through the galaxies to the edges of our known universe, this neural network of gas and energy, and then to the great darkness that who knows. Okay, so here we have another visualization of cosmic dawn. One of the most important gaps in our understanding of the universe is this period, 50 million to 1 billion years after the Big Bang, when the first stars, black holes, and galaxies in the universe formed. And one of the best ways to observe this is radio astronomy, which can observe the spin flip radiation from the hydrogen that pervades this early universe. We have the dark age, we have the initial energy of the Big Bang. We're using the image we have of the cosmic microwave background here. What it looks like is pure energy. But then we have the dark ages, the age of reionization and cosmic dawn, and then the universe as we begin to understand it here and our observation point. So what we're finding that's fascinating is that the galaxies were mature much earlier than we would have thought than our models. The Hubble, Alma, and other telescopes are telling us that the universe knew what it was doing when it started. It kind of reminds me of us thinking, oh my gosh, maybe the infant is conscious in the womb because they're coming out of the womb telling us about things that happened when they were in the womb. So the early mature galaxies have structure and molecules and different aspects that are very similar to the modern universe, much sooner than we would have assumed if it was a random dynamic. When the universe was only 1/10 of its current age, its galaxies experienced a growth spurt. It was this period that the scientists in the Alpine Alma Large program to investigate carbon at early times, the acronym project, focused on when they used the European Southern Observatory's Alma telescope to carry out the first ever large survey of distant galaxies. To their surprise, these galaxies observed in the early stages of their life were far more mature than expected. JWST's recent observations of 2 quasars from the universe's infancy gave us crucial insights into the early relationship between black holes and galaxies, echoing the mass relationship seen in the recent universe. From observations, we found that the ratio of the black hole mass to the host galaxy is very similar to those in the modern universe. The results suggest that the relationship was already in place within the first billion years after the Big Bang. So something knew what it was doing in the universe. It seems that whatever we call consciousness, and consciousness is just a word, universe means the one song. These are all words that we're using to try and fathom this amazing, awesome reality, this dynamic that we're part of. So here we have these little tiny, for us, early galaxies, 13.1 billion years ago, 12.9 billion years ago. These little galaxies we're seeing with the James Webb telescope. And we're finding that they're much larger and much more structured, even though they just look like blobs to us, but they have more dynamics going on than we would have assumed. They're 3 to 10 times more massive than we would have also assumed. So we have a giant galaxy mega merger in the early universe. Alma and the Apex telescopes peered deep into space when the Earth was 1/10 of its current age and witnessed the beginning of a gargantuan cosmic pileup, the impending collision of young starburst galaxies. So this is how the universe accreted. These smaller galaxies, first clumps of dust and gas, molecular gas, came together, forming these early stars, creating this dynamic nuclear reaction that forms all the particles from hydrogen to helium up to carbon and oxygen, all the way up the chemical chart to iron inside these stars, and then exploding stars that form the higher elements, and then these stars that form galaxies, galaxies colliding together to form larger galaxies. This is the accretion process of our universe. Astronomers thought that these events occurred around 3 billion years after the Big Bang. So they were surprised when the new observations revealed them happening when the universe was only half that age old. These ancient system of galaxies are thought to be building the most massive structures in the known universe, the galaxy clusters and the filaments that are like a neural network of dark energy, dark matter, and galaxies that fill space. Okay, Abell 2255, this merging massive galactic cluster. Hot plasma. The Abell set of Abell galaxies are some of the most huge clusters of galaxies that we've had the delight to image and map. So this is Abell 2255. That's its phone number if you want to go find it. It's hot plasma. There is hot plasma merging in this galactic cluster, unprecedented and predicted to be filled with shocks and turbulence that may convert part of the kinetic energy into relativistic electrons and magnetic fields. So the universe is extremely dynamic, especially the early universe in this formative stage. And a really exciting development in our modern astronomy is that we're able to combine these different frequencies. Radio, this particular one is the LOFAR Observatory in Europe, which is a magnificent instrument. Another time we'll explore some more of the dynamics happening from the information we're getting from LOFAR. ROSAT is an X-ray telescope, and the SDSS, the Sloan Digital Sky Survey, gives us this whole repertoire of material and images in the visible to explore. James Webb is imaging more distant galaxies that form faster than the scientists ever thought. These bright red dots believed to be distant galaxies as they would appear 13 billion years ago. But it's very shocking to the astronomers because they're more dense and more developed than any galaxies they would have imagined at that stage. Therefore, it suggests that life could have existed much earlier and before previously thought, because we have these really early dynamic galaxies that then form the molecular elements. About within 500 to 700 million years following the universe's birth, it reached levels comparable to those in contemporary galaxies. So here we have new findings that reveal the abundance of oxygen in the early universe. This was not assumed. That oxygen is one of the most important elements for early life. For life to begin. As we know, life like ours, there are, of course, the potentials that infinite different kinds of life exist, infinite different life in different frequencies, but life like ours needs oxygen. So that it was there at the beginnings of the universe is very telltale that the kind of life we're experiencing and participating in could be all over the universe. Aspects is a 3D survey of gas and dust in distant galaxies. This particular survey focuses on the Hubble Deep Field and maps the radio frequency from Alma with the molecular gas and dust in these galaxies up to Z4, the redshift, how far into the universe, which is 1/8 of its current age. This interstellar medium constitutes the matter out of which stars form and is a prerequisite to the star formation process, which drives galaxy formation. The data provides the most sensitive images available to date, disclosing the dust that was heated up by star formation. So let's look at this particular survey. This is the golden age of star formation, of galaxy formation that we're looking at here. And looking at the millimeter wavelengths with the abundance of star-forming galaxies at different points, approximately 10 billion years ago. And it's much earlier than the astronomers thought. So we're going to look at a visualization of this. The Aspects project, looking at the Hubble Deep Field. So this first is what the Hubble sees. And then we move to 3D. We see this, and you'll watch these little dots appear. The red ones, and then the yellow. So that's what Alma sees in radio frequency, these different galaxies that are hidden by invisible light, but we see in radio frequency across the early universe. And it's really exciting that we can combine these insights so that we understand what's happening in more dimensions of our universe. Okay, so astronomy loves acronyms. We have lots and lots of surveys with all these different telescopes. Alchemy. It's an Atacama Comprehensive High Resolution Extragalactic Molecular Inventory. So they use ACHEMI, and they get alchemy, the magic, the alchemy of the universe. Okay, alchemy dataset gives us a template for studying star-forming galaxies in the early universe. They found 78 species of molecules, including isotope ratios, carbon, oxygen, sulfur, nitrogen, and silicon, measured with in multiple different ionization species of these molecules, of these atoms, and an abundance of organic molecules. Shocking, huh? These organic molecules, the stuff our planet, our bodies are made of, our other planets in our solar system, they existed at this really early time in the universe. And they're finding them. we're mapping our universe like we used to map our Earth. The FANGS ALMA survey, physics at high angular resolution in nearby galaxies, is a survey of the molecular gas disks in 90 nearby galaxies that are typical of star-forming massive galaxies in the nearby universe. The survey resolves the molecular gas reservoir into individual molecular clouds and star-forming complexes that are engines of star formation and galaxy evolution. We're looking at as many aspects of our universe as we can. It's like a doctor trying to understand the human body, or the forming of the whole nature of the body of our universe. This survey includes 300,000 molecular dust clouds. And why are these important? We'll look at that. We have all these different elements and organic molecules that we're finding, looking with the radio frequency through the visible light into the early hearts of these galaxies. This is a combination from JWST and ALMA. So we're combining the infrared, the visible, and the radio. So here we have ALMA spots, a monstrous group of baby galaxies cradled in the dark matter filaments of the universe. So this is where they think that the galaxies formed in the nexus of the cosmic filaments at the centers of these web-like structures. This is 11.5 billion years ago. This is, of course, an artist's rendition, but it's a rendition of the data that we have of this young cluster of galaxies forming in that neural net of dark energy, of dark matter, where the galaxies formed as a prototype for the condensation. So ALMA and JWST, that's the James Webb Telescope, which I think most everyone knows now, is showing this wonderful group of galaxies, Stephan's quintet, the 5 galaxies, and there's an intruding galaxy colliding with their nexus. And it's helping us understand how turbulence influences gas in the early universe. It is 270 million light years from Earth in the constellation Pegasus. So that is relatively close to us. So we're beginning to near our vantage point, and we're looking at these developments, which were actually explored much earlier than the distant universe. So I can't actually see the top of my my computer here with all of the gizmos, but we have we're solving the cosmic mysteries with the multi-frequency universe here. NGC 1068 is a dynamic star-birthing galaxy with an active galactic nucleus, an AGN, meaning a supermassive black hole in its center. It births new stars at about 10 to 300 times the rate of the Milky Way. Now, astronomers have mapped its core dynamics in all different frequencies, from long radio waves to high-frequency gamma rays, using all of our different telescopes. ALMA is peering into the supermassive black hole dynamics in its core, where jets interact with molecular gas in a dance of flaming dust. So we have the optical image from the Hubble. We have X-ray images from a telescope called NuSTAR. It's exciting that all these telescopes are able to give us this combined insight. We're looking at the morphology in these early galaxies, and we found that 1 billion years after the Big Bang, we have actual spiral galaxies. And we didn't expect them to have structure at that early time. This galaxy we found is 1/3 the size of our Milky Way. It's the furthest detection of a galaxy's magnetic field we also found at 11 billion light years away. These are different data sets that our astronomers are garnering from our early universe using our Alma telescope. We see this magnetic field here when the universe was just 2.5 billion years old. That's a baby universe for us. And the results provide astronomers with vital clues about how the magnetic fields of galaxies like our own Milky Way came to be. So this, if you watch, we can see this shift here in a two-dimensional image between the galaxies that we see in different frequencies. We see the visible, and then we see the radio images. We see this shifting. On the large scale, so the largest scale structures in our universe, the largest scale of our universe. So Alma has discovered these very important organic molecular clouds, organic molecules in the molecular clouds, in the large Magellanic Cloud. So here we're dealing with the neighborhood. The Magellanic Clouds are two relatively small galaxies that orbit our Milky Way galaxy in the southern hemisphere. Magellan found them, the explorer who went to the southern, the southern dimensions of our planet with his boats. He found these two gas clouds. You can see them with the visible eyes. So they're called the Magellanic Clouds, these two little galaxies. So astronomers have uncovered the fingerprints of methanol, dimethyl ether, and methyl formate. We may or may not be familiar with these, but they're imperative to the formation of life. And we found them in the Large Magellanic Cloud. The far infrared image on the left shows you the full galaxy. The zoom in image shows the star forming regions observed by Alma. It's a combination of infrared, visible, and radio light. The two latter are unprecedented findings and stand as the most complex molecules ever conclusively detected outside of our galaxy. These observations provide insights into the formation of similarly complex organic molecules in the early history of the universe. Thus, we're thinking life could have formed so much earlier than us. So we don't know what's out there. We're still looking. And Alma was very key in there are many radio telescopes around the world that create the Event Horizon Telescope collaboration. It's 8 radio observatories across the planet forming a single Earth-sized virtual telescope that produced the first ever images of a black hole revealed at the center of the massive galaxy Messier 87. And also in the center of our galaxy. What these radio telescopes and Alma has particularly contributed to is understanding that there is this magnetic field line very close into the black hole. And you see these lines here that are 55 million light years away. It's still near compared to the early universe, but we're understanding what the dynamics are. And also, just in speculation, it's like we don't know what's happening in these cores of our galaxies where the black hole and this tremendous, tremendous energy is interacting with dust and gas and early stars. So whether this looks at all these conjectures from science fiction, white holes and other dimensions, we don't know what all of that implies, and we're studying it, these cores of early galaxies, to try and understand what the actual physics might imply, especially in the distant early quasars, like the galactic cores of the stars. So here we're looking 12.7 billion years ago at quasars very far away. And the compact cores, they're shining much brighter than their host galaxies. So we can see from their light what the composition is of these early quasars, the galaxies. We also are seeing by what we call...
How is gravity like nature's magnifying glass?
1 second here. We're seeing gravitational lensing, which helps us to understand these more distant images. Alma discovers rotating infinite galaxies with the help of the Natural Cosmic Telescope. The images of galaxy cluster, I'm not going to tell you its phone number, taken with the Hubble Space Telescope, combine with gravitational lenses imaging the more distant galaxy at 12.4 billion light years away that Alma sees in red, which is hiding underneath our image here. But due to the gravitational lensing effect by the galaxy in the front, the image behind it is intensified and magnified, and it appears to be divided into 3 or more parts. So let's look at this. 2 minutes of understanding how gravitational lenses actually work.
To find out what the universe was like in the beginning, we need to study the most distant galaxies, whose light has been traveling to us for billions of years. But the farther away a galaxy is, the fainter it appears. That makes distant galaxies very hard to see, even for the most powerful telescopes, because they can only collect so much light. Fortunately, nature can provide a helping hand. According to Einstein, the gravity of massive objects can be so intense that it can warp the fabric of space-time. Light, which normally travels in a straight line through space, can show us where this distortion occurs. A very massive object will warp space and bend the path of the light. In a sense, warped space acts like a magnifying glass. A magnifying glass collects and bends light, making a light bulb, for example, appear bigger and brighter. Warped space can do the same thing to light from a galaxy. So what acts like the biggest magnifying glass in space? Galaxy clusters are the most massive things in the universe. How is gravity like nature?
We lost the end of it there. So galaxy clusters are the most massive magnifying glass in the universe, and they're helping us see the distant universes. They're the distant universe, the dynamics of the distant universe. Galaxy clusters and gravitational lenses are gorgeous. They're some of the most beautiful things, in my humble opinion, that we're actually seeing in our universe, and having the ability to begin to understand. So we're going to look at some of these beautiful, beautiful galaxy lenses at the edges of cosmic dawn here. This particular galaxy cluster magnifies and distorts the image of a galaxy at a distance of 17 billion light years, enabling astronomers to study it in detail. So this is our galaxy cluster in the front, and these arcs of light are the distant galaxy that we can understand the implications of. As we add the light arcs together, we get an image of what that galaxy cluster is behind the one in the front. Okay, more gravitational lenses. This is really fascinating because it's the first time we found supernova in this distant lensed galaxy. We have 2 supernova here in the arc, in the lensed arc of this distant galaxy. So in our more nearby universe, NGC, New Galactic Catalog, and its phone number, 1300. This is a composite from different radio and visible images. The JWST, Hubble, the Very Large Telescope, and Alma made a composite. This galaxy, we're seeing a supernova in a star-forming region in its spiral arms, and it's marked by the image here. There's a supernova in this galaxy that we're seeing in all these multi-frequency dynamics. The supernova, we observed it after 5 days, and then again several times up to 21 days just after the explosion. So we're really beginning to understand the physics and the dynamics of supernova. And of course, that implies more about how we got here, because supernova create all these higher elements on the chemical chart that we're made of. We have another beautiful gravitational lens here, the bending of space-time, gravity as a lens. This particular cluster smacks, and there's its phone number with a large number of lensed background galaxies. So in addition to giving us so much information about the early universe, these images are incredible to me. They're so beautiful. I hope you agree with me. I would think that you do, but it's so awesome to think we're looking at a time machine with the light. Light itself is like a time machine as we look back into the early universe. And maybe, I mean, who knows if we're looking back at early stages of ourselves somewhere out in the distant universe. Who knows? Different dimensions, different stages, different evolutions of our solar system, of our Milky Way galaxy, of all the stuff we're made of, all the history of the whole universe across dimensional time. We have a triple image supernova here from gravitational lenses, which was found by JWST. It is the most distant supernova that was ever discovered, and it has 3 independent images, so we can really see into these dynamics. The extraordinary gravity is aligned with many rich star-forming background galaxies, and it could be the key to solving astronomy's greatest modern puzzle, which is the Hubble tension, the expansion rate of our universe. I love these galaxy clusters, the gravitational lenses. They're like the bouquets of the cosmos. That's what I think anyway. They are. Okay, so M74, the galactic elegance. This is one of the most perfectly beautiful spiral galaxies. So the grand design of spiral galaxies, it's used as an archetypical example. And we're looking at its equatorial, it's in the equatorial constellation of Pisces, about 32 million light years away from Earth, again, the neighborhood. It contains these beautiful spiral arms, and we're looking at it from here in different kinds of light. The visible, the radio, the infrared. We're also, from JWST, we're understanding how a pulsar, these cores of ancient exploded stars, like the corpses of supernova, how they form. So 1987A, this beautiful supernova, exploded star in our very nearby galaxy, the Large Magellanic Cloud. This was just when I was beginning to study astrophysics. And I remember when it exploded, and it's gone through so many beautiful stages. We've been able, for the first time, to watch this whole evolution of a supernova. And at first, we didn't see it's only 165,000 light years away. So it is quite close to us. And we didn't see the signs of a pulsar forming, the core collapse before, but we're beginning with James Webb to find that it may actually be forming this very dense core, a pulsar, which is pure neutron stars. So it's very heavy pulsing corpse of a supernova in the core. And it's just, we think, maybe beginning to form one of these. So we're watching this whole process as the supernova 1987A is evolving. So we're looking into the hearts of molecular clouds in these galaxies and finding how they form. This research discovered 23 molecular clouds that show different types of star formation. The large bodies in these clouds were not visible like normal molecular clouds, only in the dense heart of these galaxies. The discovery provides an essential clue to how the physical processes that generally lead to star formation occur. So we might think, why should we care about dust? We want to get rid of the dust, right? No, we are dust, but it is amazing dust. What is dust? We need dust to form planetismals, early planets. When you simulate a disk for forming a solar system, whether you have small grains or large grains determines whether you have a small or a large disk. This is how the dust couples with the magnetic fields and how the angular momentum, the spin, is transported. Thus, whether you have small or large grains of dust can tell if you can form planets, planetismals, and which kind of disk, which kind of a nebula for a protoplanetary nebula you can have. So dust matters. Dust allows for the streamers, the shocks, which lead to the planetary disk formation. So what we're looking at here is baby stars being formed. It's stellar embryology. In the early universe, structures were seen for the first time in these early protoplanetary disks. An international team has found rings and spiral structure in very young planetary disks, demonstrating that planet formation may begin earlier than thought once more. Alma's early observations of young protoplanetary disks reveal many beautiful rings and gaps, which are possibly the formation sites of planets. And yes, we have taken images of planets in formation, just at the early beginnings with JWST. Alma provides the deepest dust polarization images of any protoplanetary disk captured thus far, revealing details about how these grains and disk structure actually form in the disk. We have also found, and this is precious, wonderful, the first moon-forming disk found around an exoplanetary system in Planetary Disk System 70, located nearly 400 light years away. It features a star at its center and at least 2 planets orbiting it. And here's this tiny, we think this is a moon orbiting one of the planets. Stellar embryology, that's what we're studying. That's what we're learning. How baby stars form, what their structures are. We're cosmic doctors analyzing the structure and the formation of the living universe, the protostars, how we got here, how life emerges, how form emerges, how our universe is born. COMPASS is another survey of protostars and the spectra of all these molecular dust clouds in the in our universe. We're learning about astrochemistry and solving these puzzles. It opens the door to wideband analysis of chemical complexity in young stars in a systemic manner. The targeted protostars are known to host complex organic molecules with sampling different natal environments at different evolutionary stages. The spectra coverage allows us to unambiguously identify complex organic molecules and their isotopes. So we are learning that the universe is filled with all of the stuff that we find in our world. Tau Tauri protoplanetary disk is a young disk, only 450 light years away. We see the bands of this early, the planets are most likely forming in these bands of dust and gas around its central star. We also have the first image of the water snow line in a protoplanetary disk. So Jim has been telling us that the James Webb says in our news that maybe it's found a living planet. This has been going on, this progress to understanding that we may have planets that could harbor life at many, many stages. So it's getting more and more evident to us that these planets have the capacity to have life like ours, or similar or different from what we understand. There was a dramatic increase in this particular protoplanetary star that allowed us to look more deeply into its gas and see that the water snow line was pushed out to a greater distance and we could observe it. So we have found water in these disks, and it means we could have all kinds of different planets. Perfect pitch in the D sharp of Alma. D sharp is another one of it is a disk survey of 20 nearby protoplanetary disks. We're looking mostly at all of these disks in our own galaxy. All show rings and gaps that indicate the formation of planets on shorter timescales than was expected. Fomalhaut is a very nearby, it's the 18th brightest star in the night sky, 1.9 times this mass of our sun and 25 light years distance. It has an extended disk with incredibly rich dust, maybe a Kuiper belt with like our solar system has, with the comets going around at the far edges. It's very different from our solar system. But then we begin to wonder, is there a typical solar system architecture? We don't know. So kilonova are these giant, huge explosions of where pulsars or black holes and pulsars collide together and make huge bursts of energy, the largest energy in our universe. They generate in gravitational waves that permeate space. And we have an amazing other telescope called LIGO, which records simultaneously these gravitational waves of colliding elements, colliding black holes and pulsars in our distant universe, that are telling us about the largest scale, most energetic dynamics in our universe. So I visited LIGO at the end of my journey when I was just in Louisiana at the American Astrophysical Society meeting, and it's an amazing telescope. We will explore more about some of these things at another time, but I just gave you a little snapshot of that. So we're going to look here at a wonderful adventure that Alma has done as we conclude this part of our presentation, called Alma Sounds. They have turned 32 molecular elements in the nebula of Orion into sound, and given it to all of the composers and electronic sound people to play with so that they can create Alma sounds. They're showing us elements in visible light. And the sounds are waves. So they use the light waves and change them into sound waves from each of these different elements. Radio waves vibrate about 1 billion times a second. Turn these molecules into sound waves. And you also can find them at almasounds.org. 1,468 samples of molecules, organic molecules turned into sound. We could play, so we can play star formation on our pianos and our guitars and our instruments, our orchestras of the mind. Okay, that is the first part of our presentation. We'll take a breath here. And I was listening to the early parts of Humanity Rising this year, and I thought to myself, you know, I made a presentation about cosmic eco-social systems, which was a brief history of thoughts about other worlds from various cultures. And I wanted to bring that here for us today to complement where we've been on Humanity Rising for the last couple of weeks. So our session with the Society for the Social Studies of Science, there are about 4 of us, was with the question, with the thought, the question is not, are we alone, but are we ready? The impacts of astrobiological discoveries. And this was about 10 years ago. So these thoughts are bouncing up and down in the whole endeavor of modern astronomy, especially in the last 10 years. So the Buddha and the atomists explored the ideas that there could be an infinity of worlds based on the nature of reality. The atomists, and this was about the same time as the Buddha, about 3,000 years ago. So we're back to human time and human history. This was in Mesopotamia. The atomists reasoned that since there were infinite particles, there must indeed be infinite worlds. Because of the number of atoms in a limitless universe is infinite, the random motion of the atoms must have produced a plurality of worlds. This was what the atomists thought. As Lucretius declared in On the Nature of the Universe, if the congregation and coalescence of atoms brought about all living things in our world, plants, people, and everything in between, then certainly in other regions, there are other earths and various tribes of men and breeds of beasts, the atomists thought. The Buddha Sutras refer us to more worlds than grains of sand on all the beaches of the earth. In them, Buddha mentioned that he understood the nature and thoughts of all these diverse beings on these innumerable worlds. Many of the Buddhist treatises discourse about these beings, their past and future lives, communities, abilities, consciousness, and relationship to our world and ourselves. And we may ask, what do we know of the reality of this? But we are exploring our universe with our technology. But there is one technology that we discussed in the last week on Humanity Rising, which is our consciousness. It is our consciousness that is the main tool we are using with our technology to explore our universe. And what we understand from all of our Buddhist studies that before we had these technologies, before we had our telescopes as we know them, we had the mind. And the mind is limitless according to the Buddhist teachings, and it can permeate the universe if we know the skills and the techniques and the technologies of what we call meditation. So we're going to look at what some of these sutras have shared with us. In some of them that are wonderful and remarkable, like the Vimalakirti Sutra and the Flower Ornament Scripture, the Avatamsaka Sutra, I actually did my thesis looking at the infinity in cosmology across time, from the ancient philosophy to the modern understandings in astronomy about the potential for infinite worlds. And the Avatamsaka Sutra, there's a wonderful story about that, which I'll come to in a minute, but it is one of the most cosmological of the Buddhist sutras. It is truly wonderful. I think Jim discovered that fairly recently, and it is really, really wonderful. So these sutras and others, actually that one was composed on the edges of the Silk Road in the Gobi Desert. In the 2nd century AD, the scholars from India, from China, from the whole of the Asian plateau decided they wanted to blend together all of the wisdom of Buddhism up till that time. And they gathered and had a conference, like our conferences that we have at that time, the 2nd century AD, and tried to combine the knowledge of all these different cultural systems. And the result was the Avatamsaka Sutra. All right, these various highly adept beings, the Buddhas and their colleagues and all these scholars, in the sutras, they voyage and visit our world, the beings from other worlds. They're described in detail. So they're bringing quantum transport. They're talking about this 2,000 years ago. And it's, of course, recently only in our modern science, a proposition and our UAP discourses. But they bring this into full application in these early sutras. Buddhas come from other worlds. They have conversations. They bring things. They take beings from our world to their world and show them. It's fascinating. We have these in the Buddhist and the Taoist sutras as, okay, so Buddhism and Taoism, as well as all the religious traditions, including our Western ones, expressions talk about passing away in or departing from one world and arriving at another. Superhuman entities, sometimes called angels, and higher agents working to benefit beings in this world are said to come and go at various crucial times. Cultures in Africa, the Dogon, say that beings came a long time ago and told them there were 2 or 3 stars going around the small stars going around Sirius, and up at the time we met this civilization from the Western world, we could only visualize that there were one or two. And the Dogon knew, and they told us that other beings had come and told them there were more stars that were there, that we eventually confirmed. So we have these things in our society. Also, Andrei Linde, the wonderful scientist, Russian scientist who's now here at Stanford for many years, one of the key scientists who came about with the discoveries of the idea of the multiverse, he talks about, well, maybe beings were in one universe and they disappear from that universe and appear in another universe. So even our scientists, and he is an astrophysicist, a cosmologist at the top of his field. He is a brilliant scientist. So they're also talking about the same things that the Buddhists were talking about and the others in other cultures in the early times. But we're trying to understand it now in more scientific terms, or our own scientific terms anyway. The debate on the existence of other worlds arose in Christendom in the famous 219 proposition in 1277 AD, issued by the Bishop of Paris, Etienne Tempier. Proposition 27 condemns all who hold the Aristotelian position that the first cause cannot make more than one world. This was followed by centuries of speculation, and we note that Herschel's lunaries, we started to see the moon and we thought there were canals and beings who lived on the moon. Stephen Dick's book, the wonderful author Stephen Dick, talks about this history of thoughts about life in other worlds. So the reason that the Christians had to deal with this idea is because they came across the books of the atomists and had to integrate their knowledge and their thoughts and their philosophy into their own traditions, as is the way. So we have now Vatican astronomers. We have a Vatican observatory in Arizona. And Reverend George Condoyle, who is the director of the Vatican Observatory, he is a lovely gentleman I have met, a very wonderful astronomer. He talks about how exciting the prospect of extraterrestrials is, though it must be treated with caution. The universe is so large, he says, that it would be folly to say we're the exception. It's not new in Christendom. Reverend Christopher Kobali, who is another astronomer at the Vatican Observatory, he believes that if we discover extraterrestrials, it will entail an expansion of our theology. For while Christ is the first and the last word, the Alpha and Omega, spoken to humanity in Christianity, he is not necessarily the only word spoken to the whole universe, which is obvious to some of us, but it's like, certainly. So theologians in our modern world and our ancient world have weighed in. Thomas O'Meara, professor of theology at Notre Dame, argues the history of sin and salvation recorded in the two testaments of the Bible is not a history of the universe. It is a particular religious history on one planet. For O'Meara, the central importance of Jesus, it doesn't imply anything about other races on other planets. Believers must be prepared for a galactic horizon, even for further incarnations. So these things aren't foreign to our modern theologians, contrary to what some people may think. Wait a moment here. It would seem then that for Catholics, the question of whether to believe in extraterrestrials is wide open. So now what we have, here we go. Now with our exoplanet hunting, it's at the core of astrophysics. We have 5,586 and more total planets that we found currently going around other solar systems. And it keeps growing day by day, week by week. So the universe is teeming with planets and solar systems. our possibilities, okay, I am looking here at this. With all these possibilities, I have a few speculations. If we have an autopoetic cosmos, self-creating, the poetry of the universe, self-creating cosmos, essentially cosmos as a living organism, and this has been discussed in various literature, giving rise to innumerable worlds and beings like organs, systems, cells, and microcellular integers in multidimensionality within itself. We have spectral relationships within the existing world, such that all possible worlds may exist in networked and relational sets. The atmospheres, the life forms, the evolutionary states, and consciousness of life forms in the universe. Life may move between these worlds. Panspermia is an idea, meaning that the seeds of life may be everywhere in the universe. And we think maybe even, certainly we know that water came to the earth from comets in the early formation processes. So we talk about maybe the seeds of life. These organic molecules have coalesced on our earth from elsewhere in space. As we explore the possible ecosystemic relationships between these worlds, life and its expressions, we are returned to profound ethical questions and dilemmas regarding our actions, including such things as the mass extinction of species on our own world and its effects on the abilities of our world to sustain life and its possible universal relationships and response abilities to the total universe. What if a particular species of animal or plant, and this seems logical, is Earth's conversation with the larger universe in which we are embedded? All of these cultures and species have formed as the earth has been suffused with the cosmic energy over time. It has responded with all of this immense and beautiful creativity as a dialogue with the universe. What are we doing with what we're doing to our planet? Both to our earth itself and possibly to the universe in which it is embedded. So we are finding culturally, cosmocultural sojourns with our astronomical research. All of these dynamics, our astrobiology, our new planet, it's finding its way into our culture very, very rapidly in film, in television, music, poetry, the visual arts. Our astronomy is transforming our culture. The multiverse we have in our television shows, the possible existence of innumerable other worlds, science fiction and science is convening as we are understanding dimensions of life potentials that are transforming literally our culture. The psychosocial implications of this knowledge are profound, our astrobiological discoveries. So perhaps there is room for peace on Earth and for perfecting ourselves as a species, if indeed there are countless other worlds to explore and endless creative expressions of life that we have yet to fathom. Sensing this new and endless frontier beyond our current encounter, we may be impelled to bring our world into harmony, order, and peace, indeed ending needless suffering as a foundational preparation for our future encounters. And I know Jim has been talking about this with our UAP disclosure, and it's something that as we begin to understand more and more deeply the profundity of life itself and our cosmos in which we are embedded, which we are expressions of, and most remarkably and amazingly, which we are fathoming. What is the meaning of life? What is the significance of human beings that can think, that can fathom, that can co-create on a little tiny planet in the universe? as well the vast expanse of the cosmos that astronomical and astrobiological insights are unveiling have been suggested as therapeutic for psychological suffering for those excessively focused on their personal and local dilemmas. If you're having a problem in your relationship, look up, maybe, get some space, understand yourself in the larger context, and it can give you new insights, open your heart to other possibilities about our relationship to life itself, or by those suffering from overly inflated senses of personal egos, by those in the field of psychology. Telescopes and astronomical visions have been brought into refugee camps, especially the children, opening the sky windows for those who are most suffering in our world. So the healing power of the cosmological perspective. Thus, it's difficult to consider one's own opinion the final say in a multi-billion world cosmos. It is proposed that our astrobiological frontiers may contribute to the healing of those most dire human ills, tolerating racism, war, our environmental crisis, and other domains of collective suffering. Hubris, invoking the balm of humility and further applications of collective wisdom. Blending the atomists with Einstein, we invoke the cosmological perspective, aspiring to eliminate the roots of all evil and unethical behaviors. Wait a minute here. Like war, child sacrifice, all of our children being sacrificed to vanity. It's horrific. And our ignorance. So that is the conclusion almost of my presentation about how the universe is transforming our consciousness. But I have one further breaking news piece that I would like to share with you. So very recently, we found this amazing galaxy with a huge dust cloud around it that we understood is created by intense star formation in this remarkable galaxy, this incredible bubble. And what it leads us to appreciate is that the principal investigator, James Garrison, has received a special accolade called the Grandfather Award for his recovery of a unique new stellar entity named a Charlie star, caught in transportation mode, arriving from a nearby molecular nebula in the Great Mother constellation. So here is our principal investigator and the Charlie star that he has recovered. We can even see here in this video the recovery process, which is really remarkable for our modern moment in this stellar cluster. And what we wanted to show the principal investigator is that we are celebrating with him with Astronomy on Tap. And all of you can pass around now this beautiful discovery, and as we celebrate with the bubbly new stars formation with Astronomy on Tap and new baby stars. I thank you. And that is the end of my presentation. I hope you're all still here.
Yes, we're all still here. That was beautiful. Kala, thank you so much. Little Charlie Star, little Charlie Star. It is.
It's Charlie Star, yes.
Yeah.
Our grandfather here.
Yes, thank you. Thank you. Well, we don't have much time, but I want to say that Kala will be in the after chat, so we can have a much more expansive discussion then. But your Charlie Star conclusion, Kala, brings up Sheila Spramoli's question about the relationship between cosmogenesis and embryogenesis, and what you know about the symmetry or alignments between the two, because we know that brain formation and galactic formation are on the same patterning. So speak to us a little bit about the formation of galaxies and the formation of embryos.
So this is really brilliant, and it's been discussed by people, and certainly when you have the first impulse in the embryo, you have the egg and it's fertilized by the sperm, and then you get this burst of cells. Yeah. So you have cell division. So it's just like what's happening inside the stars, where you have this tremendous energy. It's similar. Or the burst, let's say, from the Big Bang, this burst of energy, and then the darkness, and then the formation of particles and stars and elements. As above, so below is the ancient adage that we bring here. The whole of the creative process across our universe is similar from the microcosm to the macrocosm. We're looking at embryogenesis, this stellar genesis, the genesis of stars. This very similar processes are taking place at embryogenesis within any species. We're finding these networks of the mycelium, like the neural networks in the brain, like the neural networks in the universe. We're finding these reiterations of harmonics in structure and in process and in dynamics across the scales of the universe, whether it's the biological or the physical or the cosmological. All these different scales, we find very similar processes of creative genesis. So yes, there are many. And I was watching some of the astrophysicists as they were talking about cosmogenesis, and it was really funny because I had this sense they were talking about their birth. Because we're also seeing what we have the capability and the consciousness to perceive. So we are a particular organism with a particular set of senses and consciousness capabilities. So we're seeing the universe as we perceive it, according to the consciousness that we have. We don't know what else exists or may exist outside our realm of ability to perceive. We have conjectures. The multiverse is a conjecture, a possibility. What if the universe is like a burgundy, like you take the top off the universe and there are like champagne bottles of billions of bubbles of universes? Now that sounds to me like cell division in the zygote.
Yeah.
So it's like this creative dynamic is there across scales. What is our consciousness? What can we perceive? How much is it similar? How much is it ourselves we're perceiving? All these questions are definitely there. And they're very similar.
Well, I'd love to have your comment then, on the some of the emerging thinking about the ET phenomenon on Earth is not so much ETs traveling from a far away galaxy in a material spacecraft that then lands, but actually moving interdimensionally, so that they're not traveling in any way that we think of travel, like when you fly from San Francisco to Paris, but they're just moving in and out of these multiverses that are happening simultaneously with ours. They just have the capacity to do it. And for us, as you're just saying, it's outside our frame of reference. So we experience it as miraculous, but it's just operating at a higher cosmic law that they've been able to discern because they're more advanced. What would you say about that possibility?
So science fiction has has dived deep into these thoughts with wormholes and Star Trek beaming up and beaming down, and then the multidimensionality of string theory. They postulate that we need maybe 11 different dimensions, maybe infinite dimensions, in order to get the universe that we have, even the stuff. And string theory is closer to us than we don't know, but the idea that the scientists are talking about, that you need 11 dimensions that are all wound up inside of the particles in order to get the complexity that we find in our visible universe. That's what they're discussing. And so these ideas, science is talking about them, they are there. And of course, in Buddhism, there were no holds barred. So yeah, I suggest you look at the Avatamsaka Sutra, where Manjushri, the Bodhisattva, goes to visit with the monks, Vimalakriti, who is this really brilliant layman in his home, and they decide to bring all these Buddhas from other universes. And there's a whole discussion about what kind of chairs they should use for them. And there's a goddess who lives in the house who eventually switches bodies with one of the monks and freaks him out. And she's telling him he's supposed to be detached. And he's freaking out because roses are sticking to him and he's in a woman's body. This is ancient. This is like a couple thousand years old, this scripture. Yeah. Meanwhile, all these Buddhas are coming from other worlds. And one of the bodhisattvas is saying that he shrank this whole world into a bottle so that people could share and see it. But nobody in the world knew that they were shrunk into a bottle. And then he'll put it back in the other world. So they'll all be just fine and they won't even know it. Only the bodhisattvas and the Buddhas in that world will know that they went to the other world. There are incredible things going on in the scriptures. So these thoughts and conjectures, and of course the Buddha, for myself, just in terms of personal experience, I started studying astrophysics when I was, seriously, a little bit in New York. And then when I was in Asia, climbing around the Himalayas, and I had astronomy magazines, I was up at 5,000 meters, the Karakoram mountain range, studying astronomy magazines in the day, and at night, I didn't have a telescope. So I thought, wow, there's no wall in the universe. I can just send my mind out into space. So I was like, okay, I'm throwing my mind out as far as I can go into space to start to fathom that we're connected. There's nothing, we talk about these computers and all this stuff. We have manifested in technology the capacities, the innate hidden capacities of our minds that the early philosophers and meditators talk about all this stuff. They didn't have computers, so they had to do that. The Buddhist disciples, the teacher would tell the disciple, go meditate in a cave for 2.5 years, and I'll call you when I'm ready for you, when you're done, when you're cooked. And the student would go meditate, and then all of a sudden, whatever would happen, and his teacher would call him, he'd say to other people, my teacher called me back. He's 3 days walk away, and they had other capabilities in the culture and things. Even now, we'll take this with throwing a little paper airplane with a lotus blossom on it. When Tibet was most being destroyed by the Chinese, this is recent history, okay? This is in the 50s and the 60s. Recent history, even more recently than that. They were putting all of these amazing people in prison. And one woman who was put in prison was known for being like an incredible yogi, a bodhisattva, a nun who was many stories about her, mystical stories about her. And this is within our time because she lived to end up in Dharamsala a couple of years later. She's not still alive, but she was alive in our lifetime. So many of the people in prison with her at the time, they were starving and they were freezing. And they had stories that said when they were really freezing, they would all gather around her and there would be like an aura of warmth that they could all get in. And at one point she disappeared. And there are other stories like this of some of the yogis from Tibet. She disappeared and came back to the prison with the tormas. So that's tsampa, barley flour and sugar that they make in the temples. She came back and fed them with tsampa inside the prison. This is in our time. These are stories that living people were
Exactly.
So we're talking about these distant possibilities and these aliens. And when the heart of a human being, what is a human being? When the heart matures, we are not physical entities. These forms change. Every 7 years, our cells are different. Just through biology, we understand this. We don't look like we look, fortunately or unfortunately, we don't look like we looked like when we were 20. These are not, it's not the same substance. What is giving the cohesion to this identity such that it evolves, hopefully, in integrity over time? Something that is not, that we say the genes, the prototype, all of this stuff. But the more we study, there's a wonderful book, Gray Bratton, The God Code, how he's talking about how the code of the molecules is in our genetic, in our genes, the numerical codes. But there's, all I get at this point is Shakespeare. There's more than meets the eye, Horatio.
Well, Kala, thank you so much. Your mind is very multidimensional, and I want to just acknowledge you and appreciate you, and hope that you can come back down the trail for further installments, because it's every time you come on, I learn so much and appreciate more deeply the cosmos in which we find ourselves. It's full of miracles. And just to hold Sheila's question about the relationship between cosmogenesis and embryogenesis is a wonderful thought about the micro and the macro, and what's above and is below. It's a marvelous universe in which we find ourselves.
So just to add to that thought, it has been postulated, and I think maybe in Jainism, which is the teacher of the Buddha, the Jains, it was before, it's marvelous. They talk about infinite worlds in Jainism.
Mm-hmm.
They talk about the multiverse and infinity, numerical infinities. We'll do a talk on that at some point. This would be wonderful. But the idea that maybe, just maybe, it's possible these humans, as we are gestating and our consciousness is gestating, could be seeds that the universe is cultivating to then birth. And this is in the esoteric teaching, that then a human psyche is the organizer of our own biological organism. Eventually we become the organizer of a planetary organism, then a stellar organism, then a galactic organism. Maybe we're seed universes, just the cosmos seeding itself, its own reflection.
Yeah, exactly. Yeah.
Because we're baby universe, and the universe is looking at our eyes. There's no wall between the universe and this instant. We are the universe.
Yeah. Brilliant. Thank you so much.
My joy.
Okay, everyone, you can join Kala in the after session chat. You will find the link in the chat box, and you all received it in your Zoom reminder for today, but she'll be available in the after chat session. Kala, thank you so much. And then tomorrow, everyone, we're going to hear from Ren Butler, who's a specialist and did his PhD dissertation, in fact, at Ubiquity, on the intricacies of the Mayan calendar. So we're going to have a cosmic presentation from the Mayan calendar point of view for tomorrow on Humanity Rising, as we continue this extraordinary exploration of the living cosmos within which we find ourselves. Thank you, Kala. Thank you, everyone. See you tomorrow. Bye for now.